This week's quiz will be on volcanoes, all of Chapter 7. First of all will be the stuff we did in the other flip lesson, which is the plate tectonics on volcanoes as well as properties of magma. Then the second part of the week we did this information. So first of all, you drew a picture of a volcano, and this is pretty simple. The only real confusion in the textbook is the crater is, of course, the bowl-shaped opening at the top. Pretty obvious, right? But the vent, because these are labeled right at the same place. Here, I'll make this a different color. Everybody knows what the crater of a volcano is. The vent does not have to be at the top. The main vent is at the top, where the lava is coming out. You can also have a side vent. And it doesn't really matter on your picture which you label which. I would say this one's the vent just because it's pointing more to the lava, and this one's the crater because it's pointing to the shape. But that's fine. The lava, of course, is the melted rock after it comes to the surface. So down here, we have the magma chamber, which again, pretty obvious, not a big deal, but it's obviously the melted rock underneath the surface. Some people were a little confused because the picture in the book, they saw these brick-looking things. This is just supposed to show you the different layers of ash flow and different types of rock. No big deal. This is also known as the pipe. It's just the main vent where the lava is coming up to the top of the volcano. And again, the reason we want to look at it here, because when we look at other volcanic landforms that we might see, what happens is this, if the volcano is dormant or sleeping, not active, this can harden and the other stuff erodes away, and so you get these volcanic features from the very dense volcanic rock. Hang on just one second. So these next, these were the questions on the front side of that. We talked about this briefly. We'll talk about the different types of eruptions here. Let's just go over a couple of these questions, not all of them. So why does magma rise? Why does magma in the mantle rise through the crust above it? What do you think? What's causing a volcano to explode, basically? Well, convection currents are heating it, but actually up in the crust, what's happening? There's heat, there's pressure, but yeah, so it rises because it's hotter, but also as it rises, this one too, as it rises to the surface, the gases expand, right? And so that's going to create, because there's less pressure, so then it expands. So heat, convection. So basically all of these forces are causing it to explode. And so then earlier this week we talked about viscosity, which is the resistance to the ability to flow, or the stickiness of it. And so if it is high viscosity, so if the lava is very thick, if it has lots of silica in it, do you think that's going to make kind of a runny, quiet explosion or a big, huge explosion if there's a lot of thickness in the lava? Yeah. So if it's more viscosity, it's going to be more explosive. And we'll see some examples both in the video we're going to watch in a little bit and also in my next few frames here. If there's a lot of viscosity, a lot of silica, very thick lava, you get these big, devastating explosions. Pyroclastic, which means fire rock, explosions. If it's low viscosity, you just get this like lava spurting out, and it's actually relatively predictable. So in Hawaii, they have the effusive or quiet eruptions with low viscosity, and so it doesn't suddenly explode, it's just constantly erupting. and people know it's erupting, and they know the lava flows are coming, and they move out of the way, although their houses sometimes burn down. So, we'll talk about this in a minute here, but basically the explosive eruption, all that pressure builds up and then suddenly explodes, and the pyroclastic flow, I've got this on another frame, so we'll look at it there. The pyroclastic flow is ash, and it's not generally that red melted lava. It's ash and dust and big chunks of volcanic rock. We'll go over this one here in a minute. And then finally, the stages of volcanic activity. Pretty simple. We've got active. Active, self-explanatory, right? Dormant, which means what? Yeah, dormant basically means sleeping, like dormir, to sleep. So dormant means it's not currently active. It's not an imminent danger, but it could erupt again. And then there's extinct, which seems like it should mean it's not going to erupt again. But the textbook says it's unlikely. So it's not saying it's not going to erupt again, but it's extinct. It's most likely not. Okay, let's look at some pictures. We're going to come back to that. Okay, so here are these types of eruptions. One of the things you need to identify, and again, we'll see it in the movie we're going to watch, there are two very different types of volcanic eruptions. One is the pyroclastic, so it's very explosive. Pyro means fire, right? Pyromaniac. Clastic has to do with rock. It's very explosive, it's high viscosity, very thick lava, very high silica content. And so what you see in these explosions, this is a very famous explosion of Mount St. Helens. Let me just make it big here for a minute. This picture is from your textbook. This erupted in 1980, and it's a very famous explosion because it just happened to be that scientists were studying this area. One of the universities was studying. They knew this was a volcanic mountain range. It's a subduction zone, and they said, well, let's put earthquake sensors on all these mountains and the Cascade Mountains just to monitor and see what's going on. And within 2 years of when they monitored or put the earthquake sensors, Mount St. Helens started getting all of these tiny little earthquakes, lots and lots of earthquakes. So they started monitoring much more closely. And what happened, and this is actually really quite frightening, this is what Mount St. Helens looked like before. It's a composite volcano, which we'll talk about. It's just a cone-shaped mountain. It was a vacation place that many people from, Seattle and Washington and Oregon would go there. Kind of like if you had a place up in the mountains around here. So there's lakes and all this stuff up there. And they start seeing all of this pressure build up, and they could actually measure that the side of the mountain was starting to bulge out a little bit like this. And so they kept monitoring, and they got to where they would evacuate. And as the bulge grew bigger and bigger, what happened was they evacuated. It was one weekend. It was actually it was either Saturday or Sunday that it actually blew, because people were very upset because they wanted to go up for the weekend. It was in May. They wanted to go to their weekend homes, and the roads were blocked. They couldn't go. A few people went up anyways. There were people camping in the area. And but because it was being monitored, airplanes were flying by on a regular basis. So they actually have this frame by frame video of the volcano exploding, which is amazing. And so what happens when you watch this video is it's bulging out like this, and you get this massive landslide. And as the land slides down, which you see here, then suddenly there's no pressure holding it in, and then it explodes out the side. Yeah, it's in, well, we can watch a video of it. And this, it actually is very fortunate because it ended up exploding to the, I believe, like the northeast, which was pretty much mostly into wilderness area and that sort of thing. And because it exploded in that direction, probably many fewer lives were lost than if it had exploded directly to the north or to the west, where you have, like Seattle and Tacoma and that sort of stuff. This is a fascinating volcanic thing to study. If you're interested in studying this one, there's tons of information on it. Lots of good pictures, lots of firsthand accounts of people who saw it. There were people that died in this volcano, but like I said, it is one of the most studied volcanoes, anyways, uh, at all. Mostly because of just the kind of lucky situation that people happened to be studying it. Um, People were studying it, and then it exploded. So, all right, quick questions? Yeah, you absolutely can see it. And they do kind of a frame by frame of it, but yeah. Yeah, but yeah, you can. And I don't know. I mean, it's fairly slow, so it's a little more uh it, yeah, it's not constant, but yes, you can. Yeah. That's a really good question. If they hadn't been studying it, and again, they started studying a couple years before, yeah, it could have been a lot more devastating. Um, because, yeah, I don't know if people would have known. I mean, yeah, it's a volcanic mountain range, but nothing had exploded there for hundreds of years. So, in the history. Okay, so our other volcano types here, let's take a quick look. So that is the composite. Oops, that's a composite volcano, but that is the pyroclastic or explosive eruption. As I mentioned, the other type of eruption, and the textbook calls it a quiet eruption. It's also known as an effusive constant eruption, but it's the Hawaii type eruption. And so it looks more like this. It's the more runny lava. It's constantly um, it's constantly erupting, and it generally makes a lower. I mean, it can be still pretty high altitude, but it makes these more shield. It's called a shield volcano because of the shape of it, and forms generally over time. And that leads us to this. So cinder cone volcanoes are just kind of this cinder cone eruption, and they're shaped like a cone. And there are some pictures of those in the book. Shield volcano is the runny lava, and then a composite volcano. Composite just means made of layers, and so obviously you've got layers. You've got alternating eruptions of lava and of ash. These are just a few more pictures, and these are from the book. This is Mount Pinatubo in 1991. Obviously, again, a big pyroclastic eruption. Again, one that we have a lot of different video of. This is Mount St. Helens. This is a huge crater after its years after its eruption. And you see here, this is the cinder cone forming in the center. It is still active. Um, let's see. Let's go to the next page here, and that's a cinder cone there. Hang on just a second. I lost my other picture. A shield volcano. Okay, so this is on the back side of your worksheet. These three pictures, the cinder cone volcano, cinders. Shield volcano, lava, and composite volcano, which is layers of these two. Mount Vesuvius is another famous composite volcano, and there are good accounts of both types of eruptions there. Yeah. So why does a volcano go dormant or become extinct? So like with Mount St. Helens, once all that pressure blew out of there, there's nothing else to explode. It's slowly building up, but that little cinder cone in the middle, it just spits out some pressure, but all that built up pressure exploded, so it's not building up anymore. Hawaii, which is a hot spot that we talked about, Mauna Loa in Hawaii is constantly erupting, and so it's constantly spitting out that lava because there's a hot spot, an active part in the mantle that's causing that to happen. So whatever activity, either it gets blown out or or the mantle is less active there. You can also have a lava plateau. We actually have some of those. There's a map here in one of the other pages. A lava plateau is similar to a shield volcano, except the lava is coming up through cracks and fissures, so you just get a large mesa or plateau made out of lava. And many times what happens is then after that becomes dormant or extinct, other stuff grows over it. There's actually a huge lava plateau in Idaho. Don't think of Idaho as being volcanic because it's really not anymore, but you can see that the rock types and stuff there. So there's this page. Let's see what we got next here. So these are some of the other volcanic features. Here's another thing that sometimes can happen. A caldera is caldera like cauldron. So one thing that can happen is when that magma chamber blows all of the material out, then it collapses in. And Crater Lake in Oregon is an absolutely beautiful, stunning example of a volcano that is collapsed and it's extinct. This little bitty island in the middle is called Wizard Island or something strange like that. That's actually the cinder cone of where it erupted a little more. It's kind of in the middle of nowhere, but it's amazingly beautiful if you go there. Yellowstone, they think, is a super volcano, and it has probably a hot spot under continental crust there. I have. Okay, I think we skipped something here. Let me go back because I wanted to get the other side of the worksheet before we did this. Here we go. Okay, so this is the second worksheet here, or the second side. Each type of volcano, we just did that. How does a lava plateau form? We just did that. What happens to create a caldera? Just did that. Why is volcanic soil so fertile? So this is one of those funny things, like Mount Vesuvius destroyed, Pompeii. People live in the shadow of these volcanoes, so it's very dangerous. The two reasons people live there is one is if it's not active for hundreds or thousands of years, people don't remember. But why else? Why would you build whole cities nearby? Yes. It's really good farming land. It's very rich. Obviously, first it's all dead, but then once the plants start breaking it down, it's very rich, fertile soil. And so it grows stuff really well. Okay, and then geothermal energy we'll talk about. Geo means earth, thermal means heat. And geothermal energy, you can use the volcanic heat and energy to heat things. And in fact, here in Colorado, Glenwood Hot Springs, Ouray, all these places with hot springs, they use that heat to either generate electricity, they use the steam to generate electricity, or they pipe that hot water through pipes and use it to heat houses. All right, so let's take a quick look at these other volcanic features. And again, you can draw these or look at the pictures in the book. Batholith, dike, volcanic neck, sill, and geyser. So here we go for some pictures. There's a caldera. So these features are formed by magma that cools underground. So it solidifies underground as granite or igneous rock like that, intrusive igneous rock. And then the other ground around it erodes away. There's a very famous volcanic neck. And again, that's that main pipe that we saw in the volcano. Everything else erodes away. Shiprock, New Mexico. If you've driven south to Arizona or whatever, you've seen it. It's this massive pointy, there's actually a picture of it in the textbook. And it's, again, kind of seemingly in the middle of nowhere, this big volcanic neck. A sill, like a windowsill. So what happens there, here's our volcano. And then here's our dried lava. So this would be the volcanic neck, right? Yes, but once it is dried, yeah, or this would have been the pipe too. And then if there's little parts that came up here and they're kind of horizontal like this, they're called sills, like a windowsill. But again, after this erodes away, then you're left with this very strange looking thing. Well, the ground would probably not erode away from those. Oh, Devil's Tower in Wyoming, huge volcanic feature. So then the batholith is basically was the magma chamber. Half Dome in Yosemite is one of those. Dome Mountain, similar. And then a A dike is where there was, say, a crack or a fissure, and the lava came up like this, maybe didn't explode, and then again the ground starts eroding away. And quite strangely, we actually have one of these in Boulder County. Valmont Dike is a volcanic feature. It's over near Stasio Fields. So here we're going to look at some pictures. Here, this is, so this is a picture here. This is actually, this is what Shiprock, New Mexico looks like. Out in the middle of nowhere, you've got this volcanic neck. And then this is showing, again, in the textbook, you can see a little bit better. But you can see where there were vents that came up and they cooled like this. And then this here, and again, in the textbook, it's much easier to see. You see this ridge, and the top part is the volcanic area. The sill you can see here, again, it's a little bit difficult to see. It's very distinctive. It looks like a bunch of French fries. And that's the cooled magma. Okay, here are other batholiths, and that's Half Dome in Yosemite. Again, a big volcanic feature. It could cool as granite, and so these big granite mountains, we don't think of them as being volcanic, but they are. And finally, geothermal features. So they're found in areas of present or past volcanic activity. We have a lot of these in Colorado. All the hot springs we have in Colorado are because of hot places in the crust. Magma nearby, so you've got hot springs. You get that sulfury smell from the other minerals. Geysers, the water underground heats up and becomes steam, and kind of like a tea kettle, the steam bursts out. It's forced out, and then the pressure is released, and then it is quiet for a while. And then geothermal energy, as we just talked about. So that is the volcanic features and the volcanic eruptions for this week.